because they repeat themselves over time. If you think about on the trig function, your circle, well, once you go all the way around the circle, what happens? You keep repeating. So you get the same values over and over again. So a periodic function is a function that repeats after a certain length of time. The amount of time it takes to repeat is what is called the period. Sine and cosine are periodic functions. Their period. How long does it take sine and cosine to repeat? 360 degrees. We are going to stick with radians. I know. So we're going to say 2 pi. Because once you go around the circle, you repeat your value. Alright, so I want to talk about graphing sine and cosine today. Just like in algebra, if we don't know how to graph something, we always made a t-chart. So that's essentially what we are going to do here. We're going to put in some common angles, and we can always go back and add more if we need to. So my angle, we are going to do radian measures here. So 0, pi over 2, pi, 3 pi over 2, 2 pi. What numbers are those?
0, 90 degrees, 180, 270, 360.
So, yeah, I took the x values from these points on my unit circle. Okay, so what we're really doing right now is kind of like unwinding the unit circle. So we are finding sine at each of these angles. So the sine of 0. You can think about your hand trick. You could think about on the unit circle, sine is the y value. This is the 0.10. Or on our hand trick, square root of the top over 2. So sine of 0 is 0.
Is it 0 or 0?
Just 0. At pi over 2, that's like 90 degrees. What's the sine of 90?
0. 0.
Radical 4 over 2.
Oh, okay, got it.
0, 1.
On the unit circle, this is the 0.01. Our y is 1. Or we can think about hand tricks where 4 over 2 is 1. At pi, that's here. What's this point on the unit circle? So sine is 0. This point is, so sine is 2 pi. Where's that?
Back at 0.
Back at 0. So we have 0. Okay, so let's start plotting these. So this is my radians are going to go on my x-axis. So my 0, pi over 2, pi, 3 pi over 2, and 2 pi. Notice how these are evenly spaced out because the distance between them represents 40 or 90 degrees, so they're all evenly spaced. So we have 0, 0. At pi over 2, it's 1. Pi is 0. 3 pi over 2 is negative 1. 2 pi is 0. Okay, so this is giving me an idea. If I wanted to have a better idea, what could we do? Okay, we can do a graphing calculator. Can we graph more points? Sure. You know, pi over 6 would be like 30 degrees, so a third of the way through. What's the sine of 30 degrees? 1/2. Okay, what's the sine of 45?
1.
It's radical 2 over 2.
0, like, oh.
What is the square root of 2 over 2 if you're trying to plot it?
Yeah, 0.707. 1.
So it's about 0.701 or 707, so it's more. You know, if you did 60 degrees, that's radical 3 over 2. That's like 0.8. Is this a straight line or is it curved?
It's curved.
It's curved. Okay, so this is a curve. Now, since we know it's curved, do I really need all those extra points from here on out? No. What I will be looking for is, do you have the main points? The 0, 1, -1, and so forth. Your graph must be curved. If it looks like a zigzag, I am going to count it wrong. Okay, this is a curve. Does it really start and stop here?
No, keep going forever.
No, this can just keep going forever. We graphed what is called one full period because now it's just going to keep repeating itself. So we graphed one period of the graph, but you could keep graphing this as long as you wanted. It's just a wave, continues on. Domain then, what are the possible values for my angle?
Negative 1 to 1. Oh, that's domain, okay.
Domain possible angles, we can have anything because this keeps going forever. My range though,
It's negative 1 to 1.
which haven't I already told you that for sine could only be values between -1 and 1? In the first chapter we talked about what values were possible. And back then we were using SOHCAHTOA definition, but this is coming just from our graph, which is taking the ordered pairs off the unit circle and plotting them. Alright, so key points when we are graphing sine, we need the 0, pi over 2, pi, 3 pi over 2, and 2 pi. We need those quadrantal angles, the points on the x and y axis, to get our full shape of the graph. So let's do the same thing for cosine. So if we think about, you can do the hand trick, you can do your unit circle. These are the points we just wrote down. On the unit circle, cosine is the
Oh, the x.
x value. So cosine of 0 is
1.
cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, and 2 pi.
This isn't very curvy.
And again, from the points we have, we can't really tell, are these just zigzags or is it curved? And if we wanted to know, we could always put in more points. If you did 30 degrees, or pi over 6, cosine of 30 is radical 3 over 2. That's like a 0.8. At 45, or pi over 4, cosine's radical 2 over 2, which is like a 0.7. At 60, or pi over 3, cosine's 1/2. So this one, points are probably slightly off. Again, we are seeing, it's not just a straight shot down. This is a curve.
Is this curvy? I feel like this is not curved enough.
It's getting there.
Okay.
And again, does this just stop here?
No.
No, it
No.
goes on.
It's going to keep doing the same thing. We got back to where we started, and so if I ask you to keep going, we just continue to see the same thing over and over again. So what's the difference between sine and cosine?
It flips.
Yeah, they kind of look the same, except cosine starts at 1 and sine started at 0. What's the domain of this?
Negative 3 to 5 infinity.
And my range?
Yeah, or negative 1 to 1.
Okay, only hitting values between -1. So you can put as many points as you want on here, but our minimum points, we need those quadrantal angles. Right, those are the only ones we are doing on your graphing handout for today. The rest of it's going to be in our notebook. So we're keeping this one handout with what all of our basic graphs look like. So we'll have it in one place. And now we're going to continue to talk about them. So if I wanted to know if these functions were even or odd. Even, this is an algebra term. That has to do with symmetry. Even means symmetric to what?
The x-axis, y-axis.
And what does odd mean?
Symmetric to both, isn't it?
The origin.
I only know that because I know that it's mess me up so much during it.
Because you have to flip over both axes. Okay, let's look at our graphs. So when I graph sine, is this symmetric over the y-axis? If I fold this graph on my y-axis, does it overlap itself?
No.
No. Is it odd? If I fold it over the y and then take that and fold it over the x, would it overlap itself?
Yes.
Yes. What about cosine? If I flip that over the y, does it overlap?
Yes.
If I flip on this line right here, then this curve comes here, so then it does overlap.
It's also odd. Can it be both?
It cannot. It's not.
It isn't on.
It's
oh,
not
I looked
odd.
that wonkalized. Okay.
Okay, do you guys see what I mean on those? Okay, so let's talk about sine for a second. So sine looks like this. Even means if I fold this thing on this line, it has to overlap. So it'd have to be a mirror image on the other side. Did sine look like that? No. Odd means if you fold it over the y and over the x, it looks like this. So I would flip, this would come over here, and then I flip it down. That's what sine looks like. So that is odd. Not each one individually, but you have to flip over both before it overlaps.
So next to origin is what you're supposed to write down.
So cosine, if we flip this over the y-axis, you get the exact same thing on the other side. That is the definition of even. So, sine is symmetric over the origin. You have to flip over both axes before it overlaps itself, which means it is odd. The definition of odd, and this is going to be a very useful fact, is if you have a negative angle. So if I think back, like, here's the sine of pi over 4. Sine of negative pi over 4 is the opposite of that. So if you have a negative on your angle, you get the opposite of regular sine. Cosine is symmetric over the y-axis, which is the definition of even. For cosine, if we have a negative angle, so think about our cosine graph. Here's the cosine of pi over 4. What's the cosine of negative pi over 4?
The same.
The same thing. Okay, so these come from the definition of even and odd that we used in algebra, but will be a very useful fact when we go to graph. So because sine is odd, if you have a negative angle, it gives you the opposite of the original sine value. Because cosine is even, if you have a negative angle, it gives you the exact same thing as the positive value. So what I want to do is graph y equals 2 sine x and compare that to our regular graph of sine. So when we graph them, we're doing the x-axis is like our quadrant. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those should be evenly spaced to the best of your ability. I'm not taking a ruler and measuring, but if two of them are side by side and the next one's way spread out, your graph is going to be skewed, and that would be wrong.
I would be that video teacher.
You would? I'm not surprised. Okay, let's talk about normal sine, first of all. When we graphed our sine, what did it look like? Where did it...
Wiggle wobble.
Yeah. What is the sine of 0?
0.
What was the sine of pi over 2?
1.
The sine of pi?
0.
3 pi over 2.
Zero.
Okay, so this is my original sign. I'm gonna make it dash because it's like my parent function.
This is a term I haven't heard in so long. So glad I have.
So let's talk about 2 sin x. So if I said the sine of 0, your x is 0, so it's 2 times, what is the sine of 0? 0, and 2 times 0 is still 0. If I put in pi over 2, the sine of pi over 2 is 1, and 2 times 1 is 2. If I put in pi, what's the sine of pi?
Zero.
So we get 0 again. If I put in 3 pi over 2, what's the sine of 3 pi over 2? Times 2 gives me negative 2. Okay, if I put in 2 pi, what's the sine of 2 pi? Times 2 is still 0. So here is sine of 2x. What happened?
You went up real tall.
Yeah, it got tall.
You got vertically stretched.
Yes, in algebra we call that a vertical stretch because it's like taking our y values times 2.
I got kind of excited about that. I knew that one.
So it's the same general shape, but it got taller. What do you think would happen if I multiplied it by 1/2?
You get compressed.
Shorter.
It would get shorter. Okay, so a number out in front is changing those high and low points. All right, in terms of trig functions, that word is amplitude. So, yes, because we're dealing with waves. The amplitude of a periodic function is half the difference between the maximum and minimum values. I have it phrased like that because eventually we might move our graphs up or down, so we can't just necessarily say it's the highest and lowest. But amplitude is basically how far you go from the center, how far above or below that center line you go. And that's found by the coefficient, the number out in front. Amplitude is always positive. Okay, so it's like giving the height of our curve, so it has to be a positive number.
Is this the variable for amplitude? Is it just an A? So you just hope you don't do area and amplitude.
Yeah, it's a lowercase a.
Oh.
Area is typically uppercase. Alright. We're going to talk about one more. I'm going to change this. We just did sine. Let's do cosine.
That's fine.
Okay.
Oh, this one's gonna compress or no, it's gonna flip it.
Spread
Let's
it
see.
apart.
So, let's graph our normal cosine. So, my quadrantal angle, 0, pi over 2, pi, 2 pi over 2, and 2 pi. What is the cosine of 0? 1. Cosine of pi over 2?
Oh, 0.
Cosine of pi?
Negative 1.
3 pi over 2?
0.
And 2 pi?
Positive 1.
And those are from our hand trick or the unit circle, or even just as we go through these, you'll probably get so used to the shape of the graph, you'll know it. So that's our normal cosine. If I cosine 2x. So before it was my amplitude because it was out in front. Let's see what this does. If I put in a 0, 2 times 0 is 0. What is the cosine of 0?
No, cosine of 0 is 1.
If I put in pi over 2, 2 times pi over 2 is pi. What is the cosine of pi?
180. So it's pi. What?
Cosine.
Cosine of pi? Oh. It's 1. Or it's negative. Negative 1.
Negative 1.
Why?
Cosine of pi
Yeah.
is negative 1.
Yeah.
So think about on your unit circle. Pi is here, your x is negative 1.
Yeah.
So at pi over 2, I got negative 1. Okay, if I put in a pi, 2 times pi is 2 pi. What's the cosine of 2 pi?
93 is which is
No,
positive.
that's pi over 2. We're
0.
Oh,
back to 0.
One.
I'm wrong.
It's 1.
So we're getting 1 again.
So it moves it up, it shifts up.
No, it's compressed.
I haven't graphed it yet, I have no idea.
It's more frequent.
So 2 times 3 pi over 2 is 3 pi. So here's 1 pi, 2 pi, 3 pi. We're back here and we're getting negative 1 again. If I put in 2 pi,
It's going to be 1.
2 times 2 pi is 4 pi, which is back to 0. And we get 1. Do we really have a great idea of this?
Yeah.
Maybe. We know it's keeping the same shape. So let's look at what happened. If I put in like a right in the middle, between 0 and pi over 2, pi over 4. If I put in a pi over 4, 2 times pi over 4 is pi over 2. What's the cosine of pi over 2?
0.
0. Okay, if I did 3 pi over 4, multiply that by 2, we would get 3 pi over 2. Cosine of 3 pi over 2 is?
0. Because we
0.
shoved it together.
So what's happening?
That makes sense.
So that 2 is like a horizontal shrinking of my graph. How many periods of cosine did I just graph?
2.
2. I have 2 cycles. What do you think would happen if I had a cosine of 3x?
3 cycles.
We would get 3 cycles.
Crazy.
If I had a cosine of 1/2 x, what would I do?
Half a
1/2
cycle.
cycle.
Half a cycle. We would have to go all the way to 4 pi before we had a full cycle.
Okay.
So when you put a number multiplied with your angle, it's changing how long it takes your graph to repeat. What's that word for how long it takes to repeat?
Period.
Period. So that changes the period of our graph. So the period can be found by taking the normal period for sine and cosine, which is 2 pi, and dividing by the coefficient of x. If I had taken 2 pi divided by 2, I got pi. By the time I graphed from 0 to pi, I had one complete cycle of my graph.
Sorry, I heard like a cosmical sound effect back there after the scenes.
So we have talked about 2 variations of the graph. Now we're just going to practice using these a little bit. When we graph our trig functions, we are going to do the same thing every time. We're going to make a list of information. I'm typically not going to have you do parent functions and transformations. While you certainly could, some of these get a little complex and it's almost too much stuff on the graph if you try to do that. So instead of thinking about parent functions, we're going to think about attributes of our graph. So the things that we are going to do, we will make a list. And step 1, I'm going to say, tell me the amplitude. Step 2 is the period. Step 3 is the count by. Those are going to be the points on the x-axis that we need, so we get all the important ones. And we will find those. So period we know is 2 pi divided by b. Our count by is going to be the period divided by 4 for 4 quadrants. And then we'll plot our points and draw a curve. It is a curve, so it has to be. All right. So now we're just going to do a few examples. So let's say I asked you to graph this over 2 periods, and we'll talk about that 2 periods here in a minute. So I have to answer some questions first. What is the amplitude of this graph?
Positive.
Positive what?
2.
2. It's just the number in front. So positive 2. That's my amplitude. Period. How long it takes to repeat. How do we find that?
2 pi over b, which is 3. So 2 pi over 3.
2 pi divided by the coefficient of x. So that's 2 pi over 3.
So 270. No, not 270.
I'm not done, I'm just confused.
And it'll be like a reference angle of 60. In second quadrant, 180 minus 60 is 120. Count by. We do our period, and we want to divide it by 4 for 4 quadrants. Okay, if you get confused on these and you're using your calculator, sometimes we get some nasty fractions. Don't put in the pi. We do like parentheses 2/3 divided by 4,
Just do that, and then slap the pi on it.
and then slap the pi back on it. Or we could think this is like 2 pi over 3 divided by 4, so times 1/4. So that should give us pi over 6.
I thought the pi was like, that's why I was so confused yesterday. It's not all like that. It makes more sense now.
Good.
I didn't know I could just take the pi away and put it back later.
Okay. So on our graph, the amplitude is giving us like our high and low points. So my highest point is going to happen at positive 2. My lowest point will happen at negative 2. Try to space these evenly. On our x-axis, we have 5 points. We're starting at 0. And then these points have been shifted though. We don't just want to stick with pi over 2 pi because the period got changed on my graph. That's where the count by comes into play. So I'm starting at 0, I'm counting by pi over 6. So to get the next point, we add pi over 6. And then we keep adding pi over 6. So pi over 6 plus pi over 6 would be 2 pi over 6 or pi over 3. 2 pi over 6 plus 1 pi over 6 is 3 pi over 6 or pi over 2. 3 pi over 6 plus pi over 6 is 4 pi over 6, or 2 pi over 3. Have we seen 2 pi over 3 before?
Yeah, that's our period.
That's our period, which is what we said. That should be when we repeat, so that's a good sign. All right, let's talk about sign. What's the sign of 0?
Oh, 1, 0, 0, 0, 0.
And then what does the graph of sign do?
Up, down.
It goes up and back down. So at pi over 6, we should be at our high point of positive 2. Pi over 3, we should be back to 0. Pi over 2 should be my low point of negative 2. 2 pi over 3, we're back to 0. So if you know the shape, you are just bouncing back and forth between 0, 1, and negative 1. If you got confused, you could certainly just plug these in. If I put in pi over 6, 3 times pi over 6 is pi over 2. Sine of pi over 2 is 1. 2 times 1 is 2. So I'm not just making these up. I'm just using the pattern to save myself from making a T-chart on every graph. Now, how many periods did I just graph?
1.
1. I asked for 2. If you need 2 periods, you want to add 4 more points.
Okay.
Because this is like my starting point, and then we need all the way around the circle after that. So 4 more. And we just keep adding our count by. So this was 4 pi over 6 plus pi over 6 is 5 pi over 6. Plus pi over 6 would be 6 pi over 6.
Pi. Sorry.
Then 7 pi over 6. And 8 pi over 6, which is 4 pi over 3. And we just continue our pattern. where should we go from here?
Two.
Up to 2. 0. Could I have gone the other direction to get my second period?
I mean,
Like,
if you wanted to.
Yeah, you could go this way. It keeps going in both
If you
directions.
wanted to.
If I said 3 periods, what would you do?
Keep going.
Keep going, add 4 more points. It just keeps repeating itself.
Okay, that's for the beginning of my graph might not be as bendy as the end, but it's bendy, I promise.
Would it be easier to go negative?
If you're centered at 0, yes. When we start moving them left or right, maybe not.
Oh, I don't like that premonition.
Okay. Let's.
I don't think I used that word right, but
This might be our last one for today.
That's terrible.
just
Okay.
about the last one, it was not that bad.
So we have to make our list of information. I told you though, amplitude is always a positive. So think about algebra. What does a negative do?
You flips it.
Okay, so I'm going to make a note to myself that this graph will be flipped. That's what the negative did.
Can't we just put the negative on the pie then? And take the
So,
positive negative off the 3?
no, we would actually do the other. We want our angle to always be positive. Amplitude then would be what?
Value.
3.
3.
Period is
Pi over 2 pi over 2.
2 pi divided by the number in front of
So it's
x.
just 2.
So my count by is my period
It's a half.
divided by 4 for the 4 quadrants, and I get 1/2.
I'm picking this up so easily, I can't wait for it to be bad. How many periods? 2?
So on this, my amplitude is 3. So my high point would be at positive 3. My low point would be at negative 3. Okay, we're starting at 0. It takes 5 points total to get your first period. 0 and then 4 after that. Okay, but I'm adding my count by each time. So 0 plus 1/2 is 1/2. Plus 1/2 is 1. Plus 1/2 would be 3/2. Plus 1/2 would be 2. Where have we seen 2 before?
That's our period.
That's our period. Okay, cosine. Where does cosine start?
1.
At its high point. It started at 1. So since our amplitude is 3, it would be at 3, but
It's flipped.
it's flipped. So it would be at negative 3. And then you're just bouncing back and forth. So we hit our low point, our middle point, our high point, and then we come back down. Our middle point, our low point. And this is curved. And if I said 2 periods, so what would we do?
Go all the way to 8.
Not
Or
to
go to
get
4, I mean, I
4.
meant
Yeah,
to
because you
write,
double your period.
I meant to write 8 halves, 4, but then I just wrote an 8, and then I called it good.
4 more points, so 2 plus 1/2 is 5 halves. 6 halves is 3. 7 halves. 8 halves is 4. And then just continue with half.
This is not curving.
Okay. Any questions for me so far? Yes.
What is the graph used
It's just kind of like a visual of what the sine value is doing, so it can tell you when things are, if it's increasing or decreasing at a certain time. You could use it to evaluate cosine at certain values, although it's probably not the fastest means of it. It's often used, like, if you're looking at wave patterns and things like that, we see these curves show up.
Is this curvy?
Okay, we are not totally done, however, we have pretty much covered everything. I just have a few more examples that I'm going to do tomorrow. So I'm going to go ahead and give you the homework. The first 12 are all matching questions, so there's not that many that you're actually working out. Tomorrow I will finish this, And I'm probably going to add a few problems to this assignment, so it's not due tomorrow, but you should get a good start on it. Don't try to postpone everything.